Fraction division. We will first derive an approach to dividing fractions. Then we will develop a simpler algorithm for fraction division based on that approach. In practice, the algorithm is what you will use when dividing fractions, but it's important to know why it works. What are the similarities and differences for each set of problems in column A and column B? 6 divided by 2 equals 3, and 6 times 1/2 equals 3. 20 divided by 4 equals 5. 20 times 1/4 also equals 5. 8 divided by 2 equals 4. 8 multiplied by 1/2 also equals 4. 44 divided by 4 is 11. 44 times 1/4 equals 11. Well, the similarities are that the first number in both problems is the same in both columns. So we have a 6 and a 6, 20 and 20, and so on. We can also see that all of the answers are the same. So 3 and 3, 5 and 5, and so on. However, there is a difference. In column A, these are all division problems. Column B are all multiplication problems. What about the second numbers, the highlighted numbers? Do you notice anything peculiar, anything similar about these numbers? These numbers are inverses. The highlighted number in column A is the denominator of the fraction in column B. So 2 and 1/2, 4 and 1/4. This concept has a name. It's called the reciprocal. The reciprocal of a fraction is found by switching or inverting the top number and the bottom number. Remember, every whole number can be expressed as a fraction by simply placing it over the number 1. So 2 is equal to 2/1. The reciprocal of 2/1 is 1/2. You're just going to flip it over. Reciprocal of 4, or 4/1, is 1/4. Other fractions have reciprocals too. As you can see, the numbers in A and B that are highlighted are reciprocals. The reciprocal of 2 is 1/2, 1/2. The reciprocal of 4 is 1/4. This chart demonstrates a mathematical fact. Every division problem can be rewritten as a multiplication problem by finding the reciprocal of the second number. The second number of a division problem is also called a divisor. This is true for all numbers and all fractions, with one major exception. The divisor cannot equal 0. The next slide will demonstrate how to divide with two different fractions. This process is called an algorithm. Dividing by a fraction is always the same as multiplying by its reciprocal. Every fraction division problem becomes a fraction multiplication problem. So 4/5 divided by 3/7 is the same thing as 4/5 times 7/3. Convert each of these into a multiplication problem and then solve it. 3/5 divided by 8/11 is the same thing as 3/5 times 11/8. 3 times 11 is 33. 5 times 8 is 40. 1 divided by 9/13 is the same thing as 1 times 13/9. And remember, 1 times A is just equal to A. The answer is 13/9. -3 2/3 divided by 8/11. Well, here we need to first convert this into an improper fraction. So first we multiply 3 times 3, then we add 2. So 3 times 3 is 9, plus 2 is 11/3, and it is negative. Then we're going to multiply by the reciprocal, 11/8. And so we get 11 times 11, which is 121, over 24, which is 3 times 8, and it is negative. 3/5 divided by 2. Well, what's cool is that 2 is the same thing as 2/1. So look, now we have a fraction problem. Therefore, 3/5 times flip it. 1/2. 3 times 1 is 3. 5 times 2 is 10. The answer is 3/10. And there you have it.